So my third problem is a man has a farm that is adjacent to a river. Suppose he wants to build a rectangle pen for his cows with 500 feet of fencing. If one side of the pen is the river, his cows are not going to swim away because they're going to stay in it. Like, that would kind of defeat the purpose. Either way, what is the area of the biggest pen he could build? So you first start off by drawing. You could just sketch a picture. So that's the river and that's the pin. You would just label it with like just generic variables. So I'll label these two x's since it's a rectangle, and in total 500 feet of fencing. He used x plus x equals 2x because he already used this, and to find this you just subtract it from the 500. He doesn't use this side to fence. He's using like the river too, so he doesn't use any of the fencing. So you use x feet of fencing here, and since it's a rectangle, this will have to be x as well. And so he already used 1x plus 1x, which is 2x, of the 500 feet of fencing. So the remaining should be 500 minus 2x. 2x. And assuming he's using all the fence. So this is x, this is x, and generically this is what's left. So maximizing it. So maximize like the area. So to find the area is just the width times the length. So the width, you could think of it as x. So x times 500 minus 2x, and that's what you need to maximize. So according to the steps, you find the derivative, simplify, find the max and min. For me, this is probably the hard part, trying to find the right equation to use. Just trying to find the right equations to use. So before I take the derivative, I'm going to multiply. So I'm going to distribute. So 500x minus 2x squared. And then find the derivative will be just 500 minus 4x. And so the next step, it will be set it to 0 to find the critical points. So you find the derivative, set it to 0 here. And so you just solve for x. So it'll be 500 minus 4x equals 0, and just add 4x to both sides, and then you divide by 4, and that will give you 125x equals x. So that will be your maximum or min. So you could conclude this is your maximum min, but you could use the sign diagram to check if it is. So I'm going to chop it off at 0. You can't use 0 because 0 feet of fencing, it wouldn't be like a rectangle. So any number between 0 and 125. So I'm just going to use 1. So you plug into our derivative. So it would be 500 minus 4 times 1. It's going to give you 496, which is a positive number. So it's going to be going. And since it's positive, so the original function is going to be increasing. As this increases, the overall area of the rectangle is also going to be increasing. And so any number bigger than 125. So x equals 200. But you have to be careful because 500, it can't be bigger than 500 because this is sort of the cutoff. If it went beyond 250, it wouldn't work. It wouldn't make sense. So the largest number will probably be 250. And you wouldn't have a rectangle if you did that. So x equals 200. So you plug it back into the derivative again. So 500 minus 4 times 200. And that will equal negative 300. So since the derivative is negative, the original function is going to start decreasing at that point. So that tells me it increases as it approaches 125, and once you pass 125, it starts decreasing. So that is your maximum area. Always go back if they ask, just to check I would go back just to check what you're looking for. So you're just trying to find the area, or the biggest area. So the maximum is 125, so you just plug it into 125. 125 when you plug in 120, when the max area will be when you plug in 125. So 125 times 500 minus 2 times 125 will give you 125 times hold on. So it'll be still 250, and hold on, and that will give you 31,250 feet. Remember to label your feet, and that would be the biggest area you could get. Squared feet. Remember that. That's pretty much it. So that's it. Again, you just try to get the two equations from what they give you, rearrange the equations to solve one of the variables. Try to solve the simplest variable. You could look at it, and depending on the question, you could see which route is kind of easier. Plug it into the minimum maximum equation, simplify it, find the derivative, set it to 0, solve for the variable, use the sign diagram, and label it. Plug and solve, and then you just plug to solve the variable to find the other variable, into the value variable to find the other variable, and that should be, you should be all good for optimization.